So welcome to this instalment of the DSA Summer School. I'm Phil Chapman. I've got a background studying ocean science, marine biology. So this talk is about climate change in the context of Earth history. Hope to give you some understanding, some conceptual framework that I'm hoping that you might not have already, and then hoping to have a discussion really about where we go from here in a kind of conceptual, philosophical sense, because I don't think, I think there are issues that we, on the left, the socialists, have to tackle and come to grips with in a way that I think we haven't done yet, actually. So I'm going to start somewhere where my brain often starts on lots of issues. Could be all the acid as a teenager, but in space. So this is an image taken in 1990 by the Voyager 1 spacecraft. So after the Apollo missions, there was various people wanted to send spacecraft probes to explore the outer planets of the solar system. And Carl Sagan, the public intellectual, popularizer of science, was part of the team, and he was very much insistent that the last instruction that the Voyager 1 spacecraft should have after it exited the solar system, so it's beyond the orbit of Pluto, so it's like about 3.8 billion miles from Earth, was that it should turn around and take a picture of the Earth, as well as other planets actually. This was called Family Portrait, but this is the image of Earth. Actually, it cheats slightly, so this here is Earth, but it actually took it just like a fraction of a pixel on the camera, so they had to enhance it a little bit. But this is this image of the Earth from outside the solar system. And so bringing up, because Carl Sagan basically went further than anyone probably in human history to take a picture to illustrate a talk that he probably already, or a little screen that he'd already written, send a spacecraft outside the solar system to take a picture of the Earth. And he kind of, on reflection, wrote some words. And I'm just going to start reading some of those words. So he said, "Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you have ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived here, on a mote of dust, suspended in a sunbeam." And it actually kind of went on a bit of an anti-war screed, but I'll skip that, and he finished off. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. So I guess that's it's quite a good framing starting point for me. We can zoom in a little after that. So launched at the end of the 80s, but taken around a similar time. Again, Carl Sagan was instrumental in using a probe, Galileo, that was constructed to investigate Jupiter, to take some pictures of the Earth. It was using the Earth. We did a couple of transits around the Earth using its gravitational field to take it out to Jupiter. And again, wanted to use the instrumentation to take pictures of Earth. And so this image, I think, on the second transit in '92 was taken. Each frame is like about 50 minutes apart, and as you can see, it's the Moon transiting in yeah, I mean, I think we can take for granted now, like, you know, with sort of internet image searches, you know, you can get almost any image instantly without necessarily knowing what it is. Particularly images of Earth, a lot of them computer generated. But for me, these images are like kind of they're still special. Like, or, you know, as a lot of people like Carl Sagan imagine to be, breathtaking and kind of consciousness changing. For me, you know, they still kind of have that power. And this is also the same satellite. So this was the thing from the first pass as the spacecraft was moving away from the Earth. I think this is over like maybe a 14-hour period, but it's like a real picture of the Earth. Yeah, this like mesmerizing kind of sphere, black void. We can see at the bottom here one of Earth's two permanent ice sheets, Antarctica. So in its current iteration, the ice in Antarctica began accumulating from snowfall about 35 million years ago, at a time when there was no other ice accumulating on the planet. Now we have, and this is an image from National Geographic. This is just a computer-generated image by somebody of the now second permanent ice sheet that's on the planet, Greenland, and that's been there for a couple of million years. And the fact that we have two permanent ice sheets, one in the northern hemisphere, one in the southern hemisphere, denotes that we are still in, technically, an ice age. So if you have permanent ice sheets in both hemispheres, that generally goes being in an ice age. We're in one. It could possibly be confused with in an image like this, with the sea ice. So the ice here on Greenland can be a couple of miles thick. The sea ice here is floating on the ocean and expands in winter, contracts in summer. So later, just to sort of clarify the difference between the ice sheets. I mean, it's slightly a distraction. This is somewhat an excuse to show like images that I find kind of cool. But yeah, this is like these images taken from the NASA Ice Bridge missions. This is like the Greenland ice sheet near, I think, the western edge, as it sort of begins to flow out into the ice rivers, glaciers. You can see the cracking and the crevasses, and how this sort of terminate into the sea. And in a mass balance situation, the input from snowfall will equal the amount of ice that's being discharged into the ocean. As you probably know, most glaciers in the world are retreating. More is being melted away and accumulating through snowfall. Again, that's sort of a contrast with ice flows that float on the sea. And this is an animation showing the annual cycle between winter and summer in the northern hemisphere. So this takes place every year. We're approaching the minimum. So you can see the snow how it extends through the Asian landmass and then retreats right up to the Arctic. The minimum occurs in September every year, and the minimum, the volume at minimum, and the extent and area of ice has been reducing quite rapidly over the last decades. You see that this is Greenland, miles thick of ice, that doesn't melt away somewhat during the summer, but the mass of the ice isn't as significantly altered as it is on land or the ice on the sea. Yeah, so the next image, the next graphic rather, shows, so this is the volume of ice in the Arctic at minimum each year, going through each year, compared to 1979, which is when the satellite record begins. So it's just generally illustrating a trend as the Arctic has been warming faster than anywhere else on the planet, as the minimum has been getting smaller and smaller, and so scientists are speculating when the first ice-free summer will be. Not knows for sure. Some say sooner than others, possibly in the middle of this century sometime. So yeah, this image is actually better illustrated here. So this is like an alternative to that, so maybe ignore that. So this is just a sketch. This is to scale of the entire Earth history. So this here, 4.6 billion years ago, is when the Earth was formed, and this is today. But it's likely there to show the ice ages in Earth history. That is to say, as mentioned before, permanent ice sheets in both hemispheres. And you can see that they're like quite rare occurrences. For most of Earth history, it has been a hothouse or greenhouse world. These events are, relatively unusual. It's also to give a sense of time that we don't necessarily always get. So this is the first life occurred here, like the last universal common ancestor was actually not long after the Earth was formed. This is first oxygen accumulation in the atmosphere, possibly causing this ice age. But this is where life really starts to take off. Most of this history is very simple forms of life. First prokaryotes like bacteria, then simple multicellular life. It's only here where you get this vast speciation event. First land plants are here. This is not dying of dinosaurs. This is the first dinosaur. And then we go into this quaternary glaciation, which is the ice age that we're in now, and began a couple of million years ago. So you can see in Earth's history, this is a relatively short period of time, and we're going to zoom in a little closer. In fact, I'll do that now. So if you think of this little blue strip here, go back maybe a couple of million years. So we're going to zoom in a little closer and get to the second half of that. So on the right here, this graph is the present day, and this goes back in time to 800,000 years. So almost a billion years. So it's maybe half of that little strip of blue at the end. And this graph is showing atmospheric CO2 levels during that time period. These are, we know this, we have this record from Antarctic ice cores. So, I don't know how much of the science we should go into. So, getting a nod, so I'm going to a little bit. So, ice cores are drilled in Antarctica, and in the ice there is trapped air from not exactly when the snow fell. So you can imagine snow fall. So all the ice in the ice sheets is compacted, accumulated snow. So the Antarctica as a whole is a desert, so it doesn't actually snow that much. It takes a long time for the ice to accumulate. But the snow falls, and There isn't great time resolution because air still diffuses in and out of the gaps between snowflakes for quite a while, but eventually as more snow falls on top, air is trapped and keeps a record of that air in the ice for as long as the ice sheet is there, as long as that does not melt. So this is about as far back as we've gone in Antarctica, 800,000 years. These are like cores of miles deep, and you can get from both. You can melt the ice, and from the isotopic composition of the water, you can tell what the temperature was when it fell, which is pretty cool. And from the gas that's trapped inside it, you can sample that gas and find out, carbon dioxide levels. And they track very closely. The temperature and CO2 levels go up and down together. You can also examine for other things, dust particles, aerosols, etc. Anyway, I digress. So this, I drew this kind of by hand. It's fairly accurate. It does tend to go up a bit. There's a kind of upward trend here, which is like my bad freehand one. But basically, what this illustrates is over the last 800,000 years, the late Quaternary, which is, again, reiterate that ice age, CO2 has varied between roughly 180 parts per million and 280. And as it does this, the Earth has cycled between glacial and interglacial periods. So very much like we were watching the sea ice expand and contract on an annual basis, like over these longer time scales, the ice sheets expand and contract. They don't totally go away in these warm periods, and they don't cover the whole planet in the colder periods, but they oscillate. And these are vernacularly called these colder periods. So when the CO2 goes down, the temperature goes down, and the ice sheets expand. And these are vernacularly called ice ages. Technically, you know now, by scientists as well, it's very confusing. You know now that that's technically not true. The whole time we've been in an ice age for the last few million years, we're still in one. And when people talk about the last ice age, generally what they mean is this thing. They mean when atmospheric CO2 was last around 180, the ice sheets in the Americas extended to kind of Long Island. They covered like Northern Europe, so covered like the UK down through France down to the Mediterranean. And that was here. And since then, the retreat. This little, so before you get to the orange, this little blue plateau here, probably should be a bit wider, represents the last 10,000 years. So you can see already that we were at a level of carbon dioxide that is at the more or less the uppermost that we've had over that entire ice age. We were already at a level of high CO2 for the Quaternary ice age, and this period. So we were in a relatively warm phase, and this period here is basically the entirety of what's generally called human civilization has taken place in this benign interglacial. Might not mention those terms. These warmer periods are interglacials. These cooler ones are glacials. So in this interglacial, we've had, even compared to other interglacials, very benign, stable climatic conditions. And it was in this already relatively warm, high CO2 interglacial that the Industrial Revolution happened, and we have sent atmospheric CO2 levels up to beyond now 400 parts per million, way out of the range of the ice age that's been going on for a few million years, suggesting to me, although rarely hear people say this, that the ice age is likely to be over. We're going to lose on this current trajectory. We're going to lose those ice sheets. Antarctic, Greenland, they're going to go. I mean, the timescales involved, the inertia in the system, the lag means that it will take a long time, millennia, to melt them all. But that's clearly the track we're on. I probably spent too much time going on about that, but I don't know. I'm kind of. It's kind of interesting, and it's maybe a perspective that isn't often explained. So this is zooming in a little bit more. So this is like it's almost like unreadable on that. So this is just like since the end of the 19th century. There are two graphs plotted here superimposed on each other. CO2 concentration right there, red here. So yeah, you can see how the CO2 concentration again has gone up, and temperature, this is sort of annual temperature, blue is just below an arbitrary average essentially. So yeah, and as CO2 concentration has gone up in the last 100 odd years, temperature has shot up with it. Showing similar things, slightly longer time span. This was actually, I think this was from IPCC report, from, not the most recent one. Like you are here, so that was before the year 2000. And we're at, so this is temperatures from the 61. So this is, it's probably worth mentioning, so people talk about 1 and 2 degrees. You've probably heard about kind of people talking about how much warming there has been or was likely to be. It's always important to consider what baseline we're talking about, from what. This is from 61 to 90 average. Generally, there's a kind of it's compared to pre-industrial levels, which would be earlier than this. So we've seen from that average, we've seen more than 1 degree. So we're actually probably so yeah, we're tracking the models basically very closely, and these are very different scenarios for the year 2100. Right. Okay. So I'm going to do something maybe a little brave here, but just to sort of hopefully make you feel comfortable with what. I mean, I don't know your backgrounds, obviously, some of you could be scientists, but generally, scientists talk about models a lot when it comes to climate. I just want to give you maybe a little flavour so you feel comfortable with what they're talking about at a basic level. So here's the Earth. So and it has a certain average temperature at any particular moment in time. We can consider that it has assume that it's going to have a particular temperature over a long time. So how does a planet come to have the temperature that it does? Well, it receives an energy from the sun, and actually one of the first people, it's mentioned a little later, Fourier, who thought about these things, thought, well, we're receiving all this energy from the sun all the time, like, why doesn't the Earth just carry on getting hotter? Without kind of immediately thinking, well, the Earth is losing heat as well. I suppose it's less, sensory experience. You don't really experience that. So a hot body releases energy into space through radiation. We don't see that. We see the light. We can feel the heat. So there's this balance between incoming and outgoing radiation. So the further you are from the sun, the less solar radiation you're going to receive, and you're going to receive that solar radiation in proportion to your size, basically. The bigger you are, the more you're going to absorb. So very quickly, so we can say that the energy in is equivalent to the amount of energy that, say, the planet receives from its star, in our case the sun, and you can measure that quantity quite quickly. We call that S. Remember, so if you're the sun, the Earth is a sphere, But you can see what shape is that in 2 dimensionals? 2 dimensions.
Circle.
It's a circle.
Yes.
Do you remember how you calculate the area of a circle?
Diameter times pi.
Pi. Sorry.
Oh, that's the circumference. I'm sorry. Pi r squared.
Pi r squared.
Yeah.
There you go. So this is the amount of energy that you're getting from a certain distance from the sun. Times pi r squared. Now, not all of that energy. So we've seen the ice sheets. The ice sheets reflect a lot of energy back into space. The clouds reflect a lot of energy back into space. Not all is absorbed. So it's only a fraction of that that's taken in. That reflectivity is known as albedo, so symbolized by alpha. So this is just taking a fraction of this quantity to take into account the refraction of light, basically back into space. Happy with that? Okay, that's energy in. Energy out. So it loses energy, and it, just like, you know, a hotter thing, a hotter potato you take out of the microwave, needs more energy than like a cold one. So the Earth does in proportion to its temperature, because it's a sphere, to the 4th power of its temperature. It's a law set from Boltzmann, worked it out, and this is a constant, that's just a number, multiplied by the surface area of the sphere, which is that. So if you, 4 pi r squared. So if you assume that those things are in balance, i.e. you've got a steady state, the input is equaling the output, you can say that this term equals that term, which is that, right? In a steady state. So you can solve this for t, you'll have done this probably in maths. So you solve it for t, and you get that. And this here, that's how, at a basic level, making some assumptions, that's how you calculate the temperature of a planet, actually. And if you put in the value for, say, the solar constant of Mars, and from this formula, you get a temperature that's pretty much the temperature, the average temperature of Mars. It's a little off for Earth. So for Earth, if you do this calculation, you get a result of about minus 15 degrees centigrade, I think. And the average temperature on Earth is 15 degrees. So it's maybe a discrepancy of 30 degrees centigrade. Can anyone guess what the difference between Mars and Earth is? Or why there's that discrepancy?
The biosphere. People.
Well, it's the result of biospheric action. It's the atmosphere. So Mars has very little atmosphere. And on Earth we have the greenhouse effect, which keeps the planet warmer than it would otherwise be. Because of the atmosphere. Yeah, so there are various, this is sort of the basics, the greenhouse effect. By the way, at any point, if anyone wants to like shout out or ask a question or interrupt or want me to clarify or move on beyond something, please just do so. I know people always say that, no one ever does, but yeah. So the basics of the greenhouse effect. There are gases in the atmosphere, and they absorb the wavelengths of energy that the Earth. So if we hear that the Earth radiates, being a hot body, these gases absorb those frequencies. The molecular structure of them is such that they absorb these frequencies, and then they re-radiate heat. So they trap heat, basically. It's a very simple explanation. You're happy with it. I mean, so yeah, and so just put this in out of interest. This was Fourier, who I mentioned, who kind of postulated almost theoretically that the greenhouse effect would be in existence. Eunice Foote, usually ignored American scientist, and she presented a paper at the Advancement for American Sciences, I think that's what they're called, in 1856, and she'd actually done some experimental work with different gases. What did they call it? CO2 wasn't called CO2 then, like carbonic, something or other. But she did some experimental work, basically, that John Tyndall did a bit later. He's very well recognised in climate science. Eunice Foote, not really so much. you can do your own guesswork as to maybe why, but go on.
Oh, sorry. Are these slides going to be available online somewhere, or can you just get it on USB?
I think they're just on the computer, yeah.
Cool. Thank you.
Yeah, we'll also edit them into the video when it's posted.
Fantastic.
Okay. So yeah, I mean, this slide actually has been when I've sort of tried to. People often we get into. I didn't want to get into like global warming is a real kind of debate, but this kind of shows like it's reasonably well established science. You know, even this guy in the late 19th century, well, this guy calculated CO2 emissions from factories, and he kind of calculated expected Arrhenius, chemists know him, expected temperature changes from different CO2 concentrations. Didn't get it so wrong actually, but yeah, it's like the end of the 19th century. This, maybe we can skip over, this is kind of like, there's a lot of information in there actually. This is like a, pretty much the accepted now energy budget of the Earth. Like, so this is like a figure of power, watts per meter squared that's incoming from the sun. We talked about the albedo, certain amount gets reflected, and then it transits through the Earth ocean system, is absorbed, transformed, radiated, absorbed, re-radiated, and there's an overall balance. Like, so if you, that figure minus that figure, the amount that's reflected back is more or less equal to that figure. And this there's a lot of, like, this is from a paper with a lot of kind of in-depth calculations working out. People try and sort of, hone down on these figures. There's some disagreement, but that's basically the energy budget of the Earth. This figure, I think it's quite good, illustrates the rise in CO2. First of all, so you see like the years going on, 82, at different stations, at different latitudes. So this, you can imagine, this is like the South Pole, this is the North Pole, it's the equator. So these are stations plotted on this graph according to their latitude. So this is the Northern Hemisphere stations, they're represented on this map. So you can see there's a lot, and this is annual variability going up and down. So in spring to summer, CO2 levels fall because of photosynthesis, drawing down the CO2. In the fall into the winter, that matter decays and CO2 levels go up. So this is an annual cycle going up. The red dot is Mauna Loa, which is Hawaii. That's the oldest station that's been recording CO2 levels. So that's highlighted. This is the South Pole, and that's sort of plot of the average. So yeah, it's just something that often people don't realise the sort of variation in the system. You can see how there are often spikes at whatever latitude that is to do with local factors. I don't know, emissions from somewhere, whether that's biospheric, industrial. You'd have to dig down into the data. But you can see this sort of the trend in these fluctuations obviously is up, and up to an average now beyond 400 parts per million. So when you see maybe in the media, we are now at 400 parts per million. You can see that generally the picture's a little bit more complicated, but depends where. Yeah, so now we're going to go back into time actually, and we're going to track what I've sketched out here. So this is plotting, so we don't have those direct measurements. These are now taken through proxies like anthropogenic cores, but back to the 60s. So we're back, we're still at, in 1960, so we're below 320, but it's still above that 280, which has been the higher amount in the late Quaternary glaciation. So yeah, back millennia. Okay, so this now, about now is the Holocene. So this has been the warmer period of the last 10,000 years-ish, in which human civilization has risen. Then before that, there was the last ice. So this is in common parlance, the last ice age. Really, this is the last glacial before that, there's another interglacial. So this is, we call it's all within this little blue strip. Yeah. Again, it's reproducing what I've sort of sketched out there. Again, because of my ice ages here. I think that's quite good. Useful. Yes.
Why did it go up and down in the past?
Okay, so what causes ice ages? It's generally considered to be cycles in the Earth's relationship to the Sun, basically. So the precession, the equinox, so the tilt of the Earth, how that changes. There are three kind of variables in how the Earth. So the precession, there's a slight. The Earth isn't in an exact plane in its orbit around the Sun, and that kind of varies on the time scale as well. So they're basically like cosmic factors. No one's entirely. We're pretty sure that's what it is. It causes these variations. So that alters the amount of sunlight, basically, the amount of energy being received from the sun. But we're not entirely clear because the time period between the glacial and interglacials has been variously about 100,000 years to about 40,000 years. And no one's quite sure why that is.
What, how many years?
So between glacials and interglacials, 100,000 years. So that's like a block like this, or 40, which is more like this. So yeah, if you think, so this is 100,000 years. So yeah, these periods, and so the periodicity of this glacial interglacial has changed. And yeah, it is a bit of a mystery actually, and it's one of the things that Antarctic researchers, people still going out drilling cores and trying to work out.
And the glacials are like the mini ice ages within the larger ice age. Is that
Yes, correct.
Okay. Is it the same thing causing the ice ages as the glacials that?
Yeah. Yeah. Well, I mean, there's basically an interaction of factors. You can consider one cosmic and one biospheric. So cosmic is like weirdnesses in oddities about how the sun's energy is communicated to the Earth. And the other is life, right? So life actually, so this says first oxygen here, but that is actually first oxygen accumulation in the atmosphere. First oxygen is back here. And this life is drawing down CO2. So throughout all of these ice ages and hothouse periods, life has been doing stuff. And so here it's been drawing down CO2, which producing oxygen, which at the time was kind of poisonous and toxic to most life, probably caused this ice age. So and most carbon on the planet, like 90+% of the carbon, is in rocks, is held up in rocks, and that's basically the action of life. Life is drawn down this carbon. So yeah, they're complicated biogeochemical cycles. And if I was more on top of my game and hadn't been like looking after a kid for 6 months, I'd remember more clearly. And I could I'll drill into it a bit, and I'll email you some of the answers to these questions later. And I remember exactly the precession of the equinoxes and the other cosmic cycles.
Volcanic activity is a big factor too, right?
Yeah.
So there was the big.
That's not important.
Yeah. So what was the big extinction before the asteroid, before the Cretaceous extinction? That
the fourth major extinction.
Yeah, the Permian extinction. That was a big global warming event that was caused by volcanism, right?
Yeah.
So the geological activity, has a lot to do with things. Also,
And that's so. This is sort of part of the story of why we're in this period now is because of the activity of life, right? So all that sedimentary rock that's full of carbon, the cliffs of southern England are a slightly obvious example to me. It's like all that chalk. It's like it's these are marine creatures that have calcified, drawn down carbon to form their shells. These have gone to the ocean and they've accumulated and they've become rock. So there's this action of life that has reduced the amount of carbon that's cycling on short-term cycles, right? So, atmospheric carbon dioxide is drawn down into a tree that puts it into its leaves. They fall and fall, they rot, CO2 goes back into the air. There's a short-term cycling of carbon. Now, if those trees fall in a bog and it becomes anaerobic and nothing breaks them down and they accumulate, they can end up in rock, which is what coal is. So these, but on a long enough time scale, everything cycles, right? All of the crust of the Earth will get subducted, and those gases will be released. But these are longer-term cycles. So what we're dealing with basically with the problem of climate change in an era of industrialism is the tapping into stores of carbon that have been held out of short-term cycling for a long time, allowing the current climate that we have now to occur. And by releasing those gases, we're basically on a very, very short time scale, which is something I should have emphasized possibly, but the changes, it's hard to get on a graph of this scale, but the changes are very slow compared to what we're doing now, right? It's just almost, this vertical line, if you look at it on a time scale like this is pretty much a vertical line. It's like on no time at all. So the biosphere has never had to adjust to anything as quick as this. Actually, there were periods, not everyone agrees, most people agree that there have been periods in Earth history. I think that Huronian glaciation is one where the Earth has been entirely covered in ice. We call it snowball Earth. And in that situation, it's not entirely clear how the Earth ever got out of that situation, because you think it's like reflecting pretty much all the radiation that's falling on it because it's bright white. So ice has the highest albedo, pretty much, of anything on Earth. The ocean has about the highest. So replacing, so this is sort of digression, but replacing the Arctic sea ice, which is about the highest reflectivity, with open ocean, which is about the lowest. And that's a huge effect on the amount of the sun's energy that's absorbed. Anyway, the snowball Earth is thought to have ended because of volcanism, because of geological activity, breaking up ice, and then there'd be some kind of feedback, warming of rocks that would create a larger area, outgassing from rocks. But you can think of volcanism releasing lots of carbon dioxide. They can have a mixed effect as well. Sorry, I'm very much disagree. That is releasing carbon that's been sequestered by life just over a long period. They can have the opposite effect by throwing lots of aerosols in the air, which reflect and scatter sunlight, having a cooling effect. So when you drill down, so we dealt with that climate model that's called a zero-dimensional. So that climate model that we looked at, a very simple one, it's like a zero-dimensional climate model. It doesn't resolve in space or time. It doesn't say where's hot, where's cold at different periods of time. When you start doing that, it gets very complicated. But the basics of them is kind of commonly accepted physics. I'll move on. It's sort of maybe answers some of your questions.
I have more, but it's
Yeah.
okay.
Yeah, well, we're at discussion. And I'll see if I can remember the answers. I feel bad when I definitely did at one point. And and now I've forgotten. This is just sort of emphasising perhaps the fragility of what we're dealing with, like how kind of special like the atmosphere is. Like this volume, like when you're standing on the earth looking at this, like it feels like this huge thing. Actually, like if you took all of the air in the atmosphere and put it into a sphere at the pressure, the average pressure at the Earth's surface, this is how big that sphere is compared to the Earth. I mean, in some ways it's a testament to the size of the Earth, but that is the volume of air on the planet. And perhaps more surprisingly, if you do the same thing with all the water of the planet, including the oceans, wrong way, that's the volume of water there is. It's like, really, compared to the size of the Earth, it's a thin film, you know. And these two fluids are so key to life, for various reasons. So, I've got a brief explanation of greenhouse effects, some Earth history. This is a very often reproduced image of Miami flooding. We've got, this is like the threat, so with the melting ice, the thermal expansion of the oceans comes higher sea levels, which create great partial pressure of the ocean. So this is, say, South Florida, porous rock. This is drought, say sea level, this is beneath sea level, but freshwater lens here gets pushed back by saltwater intrusion underground. That's an example of issues that we face. But why did it just climate change? These included these at the end. These series of graphs are known as the Great Acceleration. So this, so on the x-axis, starting in 1750 to 2010, they were last updated. The dotted line on each of them is 1950. So you can see, like most, I feel like a teacher now. Like most of these, you can see really. I mean, 1950s is chosen as an example where so many of these things change quite radically. Like carbon dioxide going up, nitrous oxide, methane, ocean acidification, temperature, stratospheric ozone depletion, the marine capture of fish, like just like since 1950. Shrimp aquaculture, it has various environmental issues, but also perhaps a socio-economic indicator. It doesn't really take off until, I don't know, 1980. This is a huge issue where there are papers published on planetary boundaries and how we're exceeding them. One of the planetary boundaries that we're definitely kind of exceeding is to do the nitrogen cycle, kind of different issue. But again, it's like post-1950. Various other parameters, socio-economic indicators. So I guess my kind of point is here for like perhaps discussion that might want to lead away from kind of system science, and then we talk about that, is like where is kind of the left, where is socialists, where do we plan to take the world in relation to these issues? And it's not clear to me that those things have been fully thought through. It's not like we're taking power in 1789 or 1917 or 1945. Like, this era of like global capitalism, US-led global capitalism post-Second World War has changed the nature not only of socioeconomic systems, social practices, the environment on a whole load of levels, and it's kind of clear, perhaps in certain circumstances, to talk about like a new kind of attitude towards the natural world, that we need perhaps a different approach. But how is this incorporated into like our programs, like what we want to do? It wasn't very long since we had the concept of wilderness. This idea of sort of this man humanity is outside of the natural world, and anything that humanity did to interfere with that natural world was unnatural, and there's this state of wild wilderness that's beyond there that needs preserving with a fence around it. And actually, like E.O. Wilson, I don't know if you know, he's probably the most famous biologist, American biologist, writes popular books. Just wrote a book not that long ago about how he thought like half of the Earth should be given over to the natural world without human interference, without any sort of program or idea of how that would be done. For me, I don't, without critiquing that now, I just think that these are some of the issues that we need to think about. So, it's encouraging, like, for example, Ocasio-Cortez, for example, in like her platform, included, what's been called the Green New Deal that wasn't enacted at the time of, the first Obama presidency. Lots of people thought might be enacted as a way to boost the economy, whereas kind of there was more emphasis on, I believe, what's called like shovel-ready projects. So it's good that that's there, but I'm not, are we really thinking like systemically about kind of the takeaway from this, right? You look at the key probably doesn't need much explaining when we've got this here, but you look at the paler aspects, paler parts of this world in more ways than one. Kind of places like building big walls around themselves, right? And obviously it's simplistic to reduce it to this issue, but that's what's happening now, right? And what does it mean to to have like a socialist vision in one country? If that country is this country, or that country, or this country, right? What is our relation to this part of the world philosophically, perhaps, not just into what are the roles for international institutions in our vision? What is the role for the United Nations, perhaps? Like, these are things that I think, like, it's not, I don't know, I have no idea, but I just think that these are questions that need kind of serious thought. Like, maybe, there are obviously sort of dystopian nihilists who think, it's all gone too far, like, there's nothing you can do. I think that's actually, like, I think it's just optimistic for me to think that that's not true. I think there's a whole load of reasons why it isn't. But I don't know. Like, so that's, I guess, part of the evening. I was hoping, like, perhaps people would have ideas, discussion on that, or we could go more into the sort of earth, ocean science. I don't know.
Like the two camps I hear a lot about are like go back to the land,
Yes.
or like technology,
We'll
your
say
way
this.
out of it.
Yeah.
And I wonder if you could talk a little bit more about that.
I would say I'm in neither camp. I guess if I was to be like totally honest, there'd be like a part of me that would be this guy that disappeared into the wilderness with a backpack and or had some like self-sufficient kind of homestead on the coast of Ireland or something.
That's back to the land.
I know. I'm saying that's kind of that. So if I'm honest, like I start like I'm in neither of those camps. Like if I'm honest of like some sort of like inclination, like I can relate to that as a kind of something you advocate for humanity. Like, it's absurd. It's ridiculous. We can't go back like that. As for technology will save us, and this is where there are so many clear things to say here. Like, clearly technology has a role, right? We consume vast amounts of energy. We need to produce energy from renewable sources that do not consume fossil fuels. And I think there's a role, there's one of the things that's less talked about now maybe in European politics, but it's still there. There's a recent memory, it's talking about industrial strategy. In the US, it's not really talked about. Everything's just kept hush hush and funneled through the Pentagon, which is basically how this country conducts industrial policies, how like new industries are generated, huge amounts of public funds get channeled through, what you call the Pentagon system. Now, could that be repurposed? Like, yeah, there could be. I mean, in some ways, I think there needs to be beyond. This might sound like wonkish, but in some ways, like think tanks of the radical left or socialist think tanks, whatever you want to call them, go with working proposals about turning swords into plowshares. But no, I mean, definitely that as a role. However, there is that, and this was a debate very much in the environmental movement. Do you talk about technological fixes, possibilities of geoengineering that might indeed be necessary, and the argument against that being, well, that actually then takes away some of the emphasis on the need to reduce greenhouse gas emissions now. If you think, somewhere down the road there'll be fixes. But it's important to note that, the emissions that have taken place do set in train a certain level of global warming. And even if they stop tomorrow, that is the case. There's inertia in the system for these things to feed through, for that warming to feed through, for that ice to melt. So we do need to be prepared for that. And perhaps there is a role there for research into scrubbing carbon dioxide from the atmosphere. Yeah, but again, it's a bit like the politics of that. Yes.
But yeah, I think you already said this, think on the technology way out. I don't know, it's necessary because I know, we are already deep in the crisis, but that's not the only, that can't be the only solution, because that's you totally don't look at the roots of the problem when you do that. Like you said, if that's the only way to go, so you don't work on changing the source of the problem at all, which is capitalism. This can't be the only way to go. All technology way out. And I don't know.
So I think there's ways to put this into so many of the issues we're talking about. So if we carry on this starting in space and zooming in, I live one avenue over, and I've got a small kind of yard, and I just left it pretty much. We've planted a few things, but I left it, and so we've got the grass is flowering. We've got bees in the garden. You sway a bit of the grass. There's insect life. There's found this biggest iguana that I'd ever seen hiding under the cover of some grass. There, there's some birds, nothing exotic, but there are birds that now more come because there's more life. There's kind of just scattered leaf litter where there are invertebrates living. Mockingbirds come more than they used to see if there's food. Message from the landlord: you've got to cut your grass, otherwise we'll do it and charge you $100. So there's the issue of all the issues that there's very little. You must destroy the habitat that you've got. What say do I have over that? In terms of who owns stuff? These are fundamental kind of issues of the left, aren't they? It's who is doing this stuff? Who owns the land? These problems are caused by people controlling and carrying out practices on land. Who owns and controls the land? Not us. We don't make those decisions. So the issues of housing, how are houses built and constructed, not just in terms of their immediate calculated impact on the environment, but in terms of the kind of, that sound too much some sort of old style Soviet socialist, but the kinds of people they create, right? We are creations of our environment to a large extent, right? And so a lot of that is subconscious. There's what you're contained in the system that you grew up with. It's not with the landlord. It's I've explained why I let the grass grow. But it's not she's vindictive or nasty or something. It's just this fucking stupid Victorian English idea that you have to have this short, clean monoculture grass, and that's what looks good.
So are there any solutions on either side of that divide that you think are promising?
Either side of the divide that you painted between technological fix and
Yeah.
back to the land. I mean, this might be a digression, but I think, people aren't going to stop living in cities in roughly what we might, in the urban environments that we live in within the period in which we need to really think about addressing this crisis. So there's all that notion of going back to the land. It might work for a few people. If you're thinking systemically about what the fuck are we going to do on this planet, then it doesn't really filter into that. Things that would be like how to produce more people that want to become vegan. That would, you see, and it's a joke, but it's a really simple thing that you could do that actually would make a huge difference on habitat destruction. It's probably the biggest thing you can do, without getting into the numbers of how inefficient it is producing vegetable matter, converting the energy that's in that into animal protein to then consume rather than just consuming vegetable matter. So, the way to, this is a George Monbiot quote, the way to eat less soya is to eat soya, right? Like if you eat beef and stuff, the amount of soya that you're actually by proxy consuming is way, way more than if you just eat the soya. Because so much of this is grown for animal feed, right? And it's just a huge waste of land, producing small fractions of the protein consumed, huge inefficiencies. And that would make a huge difference actually to the sixth great extinction that we're going through now. And it's simple, yet a joke because it's impossible. And it's like these kind of problems that really kind of wind you up. So that would be and there are others like that. That it's almost like there's like a conceptual difficulty in imagining something like that.
Yeah, so I guess in regards to the back to the land or the tech fix or whatever, I think you hit on a couple things that are really good. People are just responding to this sort of society or the culture that that they were born into, and I think that that's kind of, it's not like an either or type thing. Like you mentioned, I think cities this, whether or not we're gonna fix things or whatever is that question is has to be answered in high density population areas. And I think that people tend to look at cities and think oh, these are everything is dead, and everything is all vestiges of nature have been destroyed. But I think if we can make cities sustainable and make the countryside or the commons accessible to everybody, I think that's probably the way that we kind of thread that needle. Because the idea of dividing the earth equally, all of the land, all of the arable land between all of the people, to me would be terrible because then all of the land would be occupied by by people, and people have even in I think the most back to the land approaches have a hugely detrimental impact on the land.
Depends what they do.
Sure, but you're always making an impact, I guess, to survive.
Yeah, but I think that goes back to kind of for me is kind of a slightly mistaken idea of what wilderness is, right? So even if you go to the Amazon, there's plenty of evidence actually that the Amazon rainforest has the diversity it does because it's grown up with humans being part of that ecosystem. Humans on small scales clear areas and move on, clear areas and move on, and there are quite ancient structures that now have been seen from space, and that it's not. So I think this idea of this fenced-off wilderness, humans are in every corner of this planet and are affecting every corner of this planet. So I think, for me, conceptually, that there's a kind of new way of thinking about this that doesn't rely on this sort of fenced-off idea of wilderness. That I think it has been historically in America, it's served a purpose. I guess with the creation of Yellowstone as the first national park in the world, but I think later work has realised that humans played a role in that ecosystem. Sorry, Ben, you were trying to say something.
No, you're still on.
So I think this sort of like almost conceptually is kind of a move that I think we need to make, and I can understand the resistance to it, particularly sort of growing up as a kind of like an environmentalist with this. I still had this sort of, you can. I suppose growing up in the UK, where we've got something. The area of forest cover now is higher, but what you call here old growth forest is something like 3% of England, and it was preserved because like dukes wanted to hunt there, otherwise or it was too steep to farm. And so like areas that you associate with the wild and wilderness, like certain spots in the Lake District, and there are places where you can feel really kind of exposed and have like 4 seasons in a day, and people do treasure as kind of wildernesses. They're not at all. Like, they're so shaped by human activity over millennia. And I don't think that's problematic. I mean, not in and of itself. Like the practices that take place there, I think, can be like there've just been moors burning in Lancashire, and the way they're managed is appalling. I grew up near the Duke of Westminster's estate, where they like managed the moorland for grouse shooting, basically. It should be again, who owns stuff, like Duke of fucking Westminster. The Duke of Westminster on one side, the Duchy of Lancaster, the Queen on the other, is basically where I grew up, like who controlled the land. And it's a total aside, but do I think that this concept of the wild can be useful? I think but as long as it doesn't have the idea that means humans don't have anything to do with it.
Sure.
Like we are of the biosphere, we are of this planet, just no less than a fox or a goose or a bird,
Yeah. But I think that the main point, I guess, is that it's who controls how we relate with it, or whatever. Like you were kind of touching on, and I think we had like social control over and social ownership over the land and over and kind of democratic control over the economy. Like I think that the way that we interacted with the land, and also the way and the decisions we made about kind of industrial planning, like you said, would be like radically different.
And I think that's important. So first part of that thinking, I would kind of like to think that we've got an idea of what we want to do with the land before we overturn the power that in this example the Duke of Westminster has here. Here there's a different non-named aristocracy, that kind of stuff. We don't want to be having this discussion like after the revolution. Probably like what the fuck are we going to do with moors? Like, it'd be good to have like a program. But when it comes to planning, I think that is like really important, because I think we need to think about how we think about that planning. Because I mean, obviously, like it's particularly kind of post-Soviet Union. It's the thing that is most sort of ridiculed about leftist programs, that they are statist and want to control and plan for everyone. And I mean, I don't at all. But you've got to who's making these decisions about how we've got to find out, take it down to basics. If you think most things are analogous perhaps to having a finite collection of resources on the planet. How are we going to use them? Who makes those decisions? At the moment, very broadly speaking, the market makes those decisions. Actually, that means that certain people in certain positions with certain powers make those decisions, not any kind of democratic control. And the argument against there being essentially that democratic control is that you can't plan for this stuff. It's really socially very difficult, which is probably true, right? But how much, just the elements that go into making a mobile phone. Actually, some of them are kind of quite rare. the thing that makes your screen conduct electricity and therefore respond to your touch. Selenium, there's only so much. It exists somewhere. Like, who's making decisions about how that's used? Coltan mining in the DRC, perhaps highlighted. Who's making it? That's been fueling the war. Does there need to be? This is like, I'm just thinking it's like the ultimate kind of bogeyman of like the American right is like some international agency, like planning for how much resources get used. But so basically it has to be a new way of thinking about how that's done. But because I guess the idea that these people are, but I think we do need to be thinking on a planetary scale about like, okay, what sort of stuff have we got on this planet? What sort of stuff do we want to do? Very broad terms, and think about it at a global level. And obviously, who's going to do that? Well, global institutions. The fear then is that then there are these all-powerful bodies that decide everyone's life. But absolutely, you need to think about inverting that hierarchy. The people thinking about those things are like the functionaries with no direct power. So I think like addressing like the power dynamics of this is perhaps very important.
So what about like anarcho-syndicalism, like Confederate kibbutz type of things, where like the workers of one product talk to the other group of workers that have like another product, and that's like how the economy is run?
Yeah, I mean, there's obviously a long history of discussion amongst the left between, anarchists, communists, and socialists.
Aside from that, though, like what about that kind of structure?
Yeah, I mean, I feel so again, like to talk about kind of my, not that I have any personal significance, but I guess I've got a privileged position here to some extent, so I might as well use it. I guess my instincts when I was younger, when I was starting to think about politics, I'd describe myself probably as an anarchist, for sure. So yeah, I'm very sympathetic to that spirit.
I don't care about different groups. I'm just more like, when we always talk about we have to do something, which we all agree.
Who's we? Like people who would, what should we do?
Yeah, what should we do?
I mean,
Not that you have the answers,
right.
but I just
so that's
what we should do.
Yeah, well, I think like discussions like this do get somewhere, and if I was really, I could take your question seriously, and I'd go home and like think about it for some weeks and write something, and I could come up with something. But I don't think that's really what I don't think it would be particularly novel or interesting. I don't know. I guess I'm sort of bringing these, like my conclusions, I think are less important, like from my perspective, as encouraging a really kind of vibrant, exciting movement in the United States at the moment, like the Democratic Socialists of America, to think about some of the things that I think we need to think about and decide upon. And I don't, my answers aren't going to be. I don't have, I'm kind of interested in Earth history and glacial periods, and I know a bit about politics. Like my answers on whether we should, go down what might be called a more non-hierarchical kind of social organisation or not. I don't have any more insight on that. I mean, I was part of Occupy for a while in London. I've got some personal experience with these things, but this is the DSA in America. Like everyone's got those experiences. Like
I'm just asking you because the chairs are facing you. But
Yeah.
I wonder for everyone.
I'm avoiding it. I'm just thinking
does
about the
anybody
debates
have
and
ideas?
please, yeah.
I'm sorry. Yeah, it's not necessarily having an idea or not. I'm just curious to know, in terms of what you're pointing out and in terms of what you presented today, how much of this, and then in terms of the stories that you shared, how much of this moving forward is a question of resetting expectations? So, for instance, resetting the expectation of having a very short mobile lawn that's not overgrown, resetting the expectation of having, multiple golf courses, resetting the expectation of being able to travel internationally on a plane and be somewhere else within,
Yeah.
6 or 8 hours. The expectation of being able to order something online and then getting it within 2 days.
Yeah.
Is it going to be a question of, has leftists kind of, I don't know, if training people is the right word, or just telling people like, okay, that's not going to happen anymore. Because one way or another it is, it's not going to happen anymore. So either people are ready for it or they're not.
Yeah, and there's no doubt some of that is going to take place. I mean, there's a problem there. You don't want to sound like Calvinist, that you sort of everyone has to sort of go into the next decades in some sort of self-denial mode, denying themselves pleasures for the good of the community. I mean, perhaps that is what we need to do based on what we assess from what's going on the planet. In which case, we need to think about how that is communicated, how we talk about that, and have the confidence to advocate for it. So I think one sense, like hoping that at this time in history, in this organisation, in this country, these issues have to be sort of discussed, certain conclusions have to be arrived at, and people have to have the confidence to advocate for them. And I have every faith that the people involved in this organisation, in this movement, do have that. Like, you just have to think about, recently something like, the idea a month ago that Trump would be able to characterise the Democratic Party as a party that wanted to abolish ICE. It's like unimaginable that would have filtered through to a Democratic Party platform. Like, that was the sort of thing that, like, one radical on a small demonstration might be holding a sign to almost like trying to go with the others into being as radical as they are. Maybe I'm wrong. I don't know this country as well as you guys, but for me that was quite exciting, and that's basically because of the a primary election in the district in New York that allowed that to happen. Sorry.
That's okay. I just wanted to say, to follow up on what you're talking about, we absolutely do need to be talking about these things and figuring out what the answers are, what the long-term answers are. But we also need, I think, to take power. That's essential. And I think that taking power and instituting things like a Green New Deal are incredibly imperfect or insufficient fixes, but at least we have to take power in some form in order to be able to even have those conversations, because where we're at right now is that we don't even have a seat at the table, and so I think that's essential to
Yeah, I think it's important to have an idea of what you want to do before you take power, but obviously ultimately having power is what we need to do. And I think to go back to your question, if I was to think of my ideal way that humans could organise society, it'd be something like you painted out, with T's crossed and I's dotted and what have you. However, particularly striking, yes, say the same about the UK. I'm living here now. I'm living under a Trump presidency in the United States of America. To a certain extent, my idea of what humanity could be like in certain circumstances aren't the circumstances we have right now. We've got to move where the openings are. I guess from certain experience, I tried picking up the sledgehammers and going the thick wall. You can only do that so much. You have to move. There are openings, there are gaps, and we've got to see where they are, and move in them, and know what we want to do when we get in them, and maybe open up those spaces, push back a bit further, move a bit further. And there's no right or wrong answer to what is the question of what is possible and feasible, what can we achieve now. It depends on the balance of what you assess. What's none of these things are easy, but to some extent, that's why I hesitate from answering that, because I think, sorry, I'm going to carry on, but I think about it. It's also with a biological background, there's so much about human personality that I think is constructed by our environment. So we have the people that we have, we have the ideas around that we have, and you can only move with what you've got, go in the direction. You can't suddenly create an anarcho-syndicalist society across Northern America like within my lifetime, within my son's lifetime. Maybe that's how people will live. Maybe you want to sort of have some teleological idea about how people might live in 1,000 years' time, and how if that was possible, would you get there from where we are now? But I don't know.
I have a science question that hopefully doesn't derail from the conversation. I'm just confused, or is it possible to rank the threat levels or something? So I don't know, maybe you can explain the difference between carbon dioxide, methane's bad, sulfur bad. So what sources, you mentioned being vegan, but then I've also heard that being vegan, that's not thinking you need to really stop, burning oil or something. And so can you rank what the biggest threats to accelerating climate change? Because then maybe we could just have an inroad into, okay, that's the biggest threat and it's relatively easy.
Yeah.
So define these things.
So first of all, the reason I didn't go into that is because that's I guess more commonly accessed, and I didn't think there was anything that I had to say that perhaps anyone can just find out from anywhere very easily. But yeah, there's a mixture. So methane is a much more powerful greenhouse gas in that it absorbs more energy from the outgoing infrared radiation. It's to do with its electron orbital structure, basically. So it absorbs more energy as an individual molecule. It has a much shorter life in the atmosphere, however. Carbon dioxide is in the atmosphere for a much longer time, and there's more of it. So that's why you concentrate on carbon dioxide. But yeah, methane, molecule for molecule, is a more powerful greenhouse gas. As are the replacement for
CFCs.
They were replaced by HFCs, different fluorocarbons. So
the chlorofluorocarbons have been replaced by hydrofluorocarbons.
Hydrofluorocarbons. So CFCs basically destroy ozone. And actually, that's an example of a pretty successful international agreement to wipe out the production of fluorocarbons. It was part of that agreement, the Montreal Protocol, did that. Part of that agreement allowed for chemical companies to produce hydrofluorocarbons as alternative refrigerants. Actually, they probably didn't need to do that. You could have probably used if there had been the research, you probably could have used CO2 to do that. But I don't know how true this is. I haven't read about it for a while. But yeah, this is sort of idea floating around that built into that was the chemical companies could produce some other sort of novel synthesized chemical to use as a refrigerant. So refrigerants around the world use hydrofluorocarbons. They escape into the atmosphere. Very, very powerful greenhouse gas. Can you rank these things? Yeah, I mean, if you think about it, those things need to be eliminated from production as soon as possible. The coolants need to be used. Globally, carbon dioxide is probably the most useful thing about systemically. Its sources in, for agriculture, to transportation. It's embedded in the food you eat, how we get around, how we power much of Western civilization. So alternative sources, there's some combination of using less energy. Again, who owns and decides stuff? I move into my apartment. My washing machine is certain size, for me, ridiculously big. It means that, the load, if I wait to put on a full load, it's then too much to hang on the line, which even though we live in, Florida and it's 30 degrees every day, no one hangs up there, I've got no space to hang out my laundry to dry with evaporation, which has worked for quite a long time. I've got to use power to, I don't, I'm trying to hang it out on the line, but there's an expectation you live in a certain way because life is structured for you in a certain way. These are the things you do. This is the size of the oven you have to heat every time you want to heat up your pie or whatever. There are systemic ways in which our life is structured that need rethinking, and it's very complicated. And I don't know if you answered the question. Going beyond just climate change, so you were like thinking within climate change, what the most important gases, what are their different sources. Yeah, I mean, hopefully I just something like that. But then climate change is one of a number of environmental issues, and there are, I can send links, there are papers that have talked about the concept of planetary boundaries, looking at different environmental issues, and ranking them. And actually climate change, its current level is rated lower than other threats. For example, as I mentioned, like the nitrogen cycle, how we're like drawing down essentially inert nitrogen from the atmosphere, introducing it into agricultural systems, we consume it, our waste doesn't cycle really, it gets flushed out locally. The Gulf of Mexico has a huge dead zone annually because of this issue, for example. So yeah.
Yeah, so I think we should probably like wrap up the live stream portion of this, but I just wonder for the folks like watching online before.
Do you know how many people are watching?
Yeah, there's like five right now at the moment. Yeah, but yeah, so I just wanted maybe to ask like what are some tangible, I guess, things that we can do here. Locally or advocate for, which obviously climate change is an immense problem. But like, I guess, what in your estimation, what are some things that we could tackle as the left in Miami-Dade County or in South Florida?
Well, I think I hate to come up with like suggestions to come up with answers rather than answers themselves again. But so locally, for example, there are active groups that have been pressuring local government on addressing the threat of sea level rise and climate change. And that has been to some extent effective. So that has led, it would probably happen in places like Miami Beach anyway, because it's so rich, to the spending of millions of dollars on protecting certain infrastructure, for example, coastal infrastructure, thinking about what the vital things to the city, the port, the airport, police stations, like, this is in the assessment of the authorities, right? Fire stations. So now some of those things we might think are priorities, some are not. But in a sense, it's protecting, again, the status quo of the city. Like, so how, how could that money be better spent to protect, huge numbers of people in the city, their basic needs aren't met, right? It's not, and the people who are responsible for implementing some of these policies are asking the questions themselves. Okay, like I want to make a difference on climate change. Live and work in Miami. Okay, this building is vulnerable, and we can protect that building. How do we do that in an equitable manner? I don't know. I don't know this. There are people that work on these things. I guess there aren't necessarily novel answers, but I would think of something like housing. Like, what could a housing cooperative that took possession of some empty land do in terms of creating some kind of living arrangement that wasn't like I and my kind of nuclear unit live on this patch of earth with a fence around me and you live over there and this is how we think about the world. We all have to have our own lawnmowers and cut our lawns, and breed that mentality. Maybe we could have a common eating area, and maybe we could enclose it so there's some common space. Maybe we could grow some of our own food. Maybe we could have solar panels. Things that people would think about, I think, in terms of that could be an answer. How would the city better spend money to address local environmental problems? I don't know, what are the issues where you live? Could there be more, again, it's not necessarily directed. There is an issue with merging all these environmental issues into one, which I have a problem with, and I'm about to do it. But how could you increase habitat in what would be, and it still is in many places, a wondrous subtropical kind of ecosystem. Yeah, I mean, I avoided answering what this is all about.
All right, yeah, thanks so much.